Hello good day viewers. In this tutorial we are going to find a solution to this problem. We would like to evaluate the definite integral of the function x plus 2 with respect to x from 0 down to 5 but for definition. So first of all I would like to evaluate it the traditional way to see the results, but in the end we are going to apply definition to see whether we are going to get exactly the same result. Okay, let's get started with this one. You know that to integrate this function, x with respect to x will give us x squared divided by 2 plus the second term, which is 2. If you integrate it with respect to x, you get 2x. The limit from 0 down to 4, right? Okay, this is 5, sorry. It should be 5. You plug in the upper limit first wherever you have x. So substituting x equal to 5, you have 5 squared here, which is 25. Divide by 2 plus substituting x equal to 5 here, you have 2 times 5, which is 10. The whole of this minus the lower limit for 0, you have 0 squared is 0. Divide by 2 plus 2 times 0 is still 0. So the whole of this will give us 0. We're only left with this one. 25 divided by 2 will give us 12.5 plus 10. And if you add this together, you have 22.5. As simple as that. So the answer is 22.5. Let me find somewhere and write it. So the area under the curve is what? 22.5. So now let us apply definition. From definition, we have the formula of the area as what? The limit as n approaches infinity of the summation of the function f of a plus k dx multiplied by dx from what? 1 down to n. As simple as that. All we have to do is to find a, find dx, substitute back, simplify and get our final answer. A is the lower limit, and you know that dx can be obtained by taking the difference between the upper limit and the lower limit divided by the number of rectangles. But talking about n as it approaches infinity, we know we have infinitely many number of rectangles inscribed under the curve. Remember Riemann integration. So let us find, we know that a is the lower limit, which is 0, and dx is equal to b, which is the upper limit, minus the lower limit a divided by n. This is equal to, b is the upper limit 5, a is the lower limit 0, so 5 minus 0 is 5. Divided by n. So dx is 5 divided by n. So let us plug them back here. But I would like to simplify the summation first before taking the limit. So allow me to simplify this first. So we have the summation k from 1 down to n of f of a is 0, k times dx. Dx is 5 divided by n times k. We have 5 k divided by n, then times dx, which is what? Still 5 divided by n. Let's further break it down. We know that 0 plus this is still this, so we have the summation of f of 5k divided by n multiplied by 5 divided by n from 1 down to n. We are still simplifying, but remember this is a function, and our function is x plus 2. So wherever we have x, we replace it with 5k divided by n. So this will be the summation of x plus 2, that is 5k over 2. Over n, sorry. Should be over n. Then plus, you know the function is x plus 2. This is our x. Then we still have plus 2. Then times 5 over n. Remember, k is from 1 down to n. So now let us simplify this from the other side. We take this, we distribute inside here. We have 5 times 5k, that is 25k, divided by n times n is n squared. And this is the summation as k begins with 1 and stop at n of, this is 25k divided by n squared. Then plus 2 times 5 divided by n, that is 10 divided by n. So we are taking summation. Remember, it is what? With respect to k. So we have k here, but this remain constant because this is with respect to n. We are talking about k. So we can factor out 25 over n squared here, because we consider 25 and n squared as constant. We are only considering k here. So we have 25 over n squared multiplied by the summation of just k, which is this one. I have factored out 25 over n squared, k from 1 down to n, plus the summation of our constant 10 over n of just from 1 down to n. So let us evaluate these two separately. For k, remember previously, if you evaluate k without exponent, it will be what? N multiplied by n plus 1 divided by 2, for which k begins with 1 and stop at n. Remember that you can watch the previous lesson. So this is 25 over n squared multiplied by n times n plus 1 divided by 2. That is the simplified version of this. Then remember, if it is just a constant, just take n multiplied by that constant. So we have our constant 10 divided by n, then you multiply by n. Let's further break it down. This n can divide this n one time. So what we have is 25 times n. If you expand, that is 25n. Then 25 times 1 will give us what? 25. Then we divide by n, right? So by 2n, sorry, because we are multiplying 2 by n. So we have this divided by 2n, this divided by 2n. Remember, this n will cancel this n, so we have 10 right here. So we have finished simplifying the summation. But since we have n cancel n here, I can still break it down into 25 divided by 2 here, plus I can write this one, which is another constant, before 25 divided by 2n. So this is what we need to continue. Remember, from here I neglected the limit and take the summation, so I'm dealing with the summation. Now it's left for me to take the limit as n approaches infinity. So the area A will be the limit as n approaches infinity of what is left, that is 25 divided by 2 plus 10 plus 25 divided by 2n. This is what we have from here. And remember that limit of a constant is still constant. So therefore, limit of 25 over 2 will be 25 over 2. Limit of 10 will remain 10. But the moment you plug in infinity here, the bottom will be very heavy. So as the denominator of a fraction approaches infinity, the whole fraction will tend to approach 0. So this is 0. And you know 25 divided by 2 will give us 12.5. And we still have plus 10 here, plus 0. And this is equal to what? 22.5. And this is our area from definition, which is exactly as the previous one. So some of you might say, oh, the traditional way is very simple, but you know mathematics is governed by some laws. So if instruction is given to you, which stated that evaluate from definition, you have to follow all these processes. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.